So I'm Patrick. I'm a PhD student based in the Geographic Data Science Lab at the University of Liverpool. And I'm going to present today a paper that has just been finished, co-authored with two of my supervisors, Alex and Les, and also Kevin, who funnily enough is due to present after me here. So this is the first paper of my PhD. It's just gone through peer review process and I've received comments this week. So I'm kind of hoping that by consolidating feedback from the peer review process and today's presentation, that I can use it to build a much stronger paper as a result. So what am I talking about today? I'm going to be talking about Chicago retail centers and how I'm defining them and using them and that sort of thing. So I'll be talking about the definitions of retail centers and the data sets that I'm using. But I'll also be kind of more focusing on the lens of kind of the where, what, and how of retail centers. So when I say where, I'm talking about where are they located, what are their geography, what are their extents. When I'm talking about the what, I'm talking about kind of what are their kind of characteristics, how can we look at these retail centers through a typological perspective. And then more importantly, probably is in terms of how we can use them, what we can do with retail center boundaries once we've extracted them. And what I thought, because this is a 20-minute presentation, so I thought I'd wrap it up quite nicely towards the end, hopefully with a quick discussion of the second paper that I'm working on at the moment, which is kind of an expansion of this research where we kind of adapt the kind of limitations of this paper to build up kind of a stronger, more national classification of retail centers for the US. So when I'm talking about retail centers, I'm thinking kind of along the lines of concentrations of retail units and their associated activities. But also we can talk about them being kind of highly dynamic in the sense that they expand, they contract, they respond to external pressures and things that go on in the retail sector. But we can also think of them as geographic entities because at the end of the day, they are used by people, they serve a purpose for economies and society, and they obviously have a footprint. It's not evident, you can't often see the footprint or the boundary clearly, but it does happen and we can look at this. A lot's been written about retail centers in the past. We've got kind of seminal works by like Brian Berry in Chicago and Brown looking at form and function of retail locations. And then in more recent times, given to kind of better method development and of data availability, there's been a kind of emphasis on comprehensive and automated approaches to doing so. And that's something I want to talk about today, particularly in terms of when we looking at the what and the where of a retail center. So what I've done is I've pulled inspiration from two kind of key papers. So when I'm talking about the where of a retail center, so delineating the boundaries, I'm talking about that modified DB-SCAN paper that Abby was just literally talking about a second ago. And then when I'm talking about building a typology, I'm looking at this recent paper by Les, who's a supervisor of mine, as I said, which basically argues that we can classify retail centers non-hierarchically through a multidimensional kind of framework. Why is this important before I get into the kind of nitty-gritty of this paper? Obviously, we all know that retail has faced many pressures in the last, well, historically, and also particularly in the last couple of decades. E-commerce, vacancy rates, the loss of these kind of major brands that sort of once characterized our high streets. But then also more recently, the kind of buzzword is the COVID-19 pandemic and the impacts that that's had on the high street. So what can we do with retail centers to assist with this effort? What I try to argue throughout my thesis and also throughout my kind of papers and wider research is that I think retail centers can be a really useful tool for helping us to understand these processes. So retail evolution, obviously, as I've said, is an inherently dynamic process. It happens over time, and it's incredibly pressing for academics and stakeholders to understand this. And I think retail centers can be a really useful tool for enabling us to take stock of some of these things so we can generate kind of national insights into present day kind of retail provision, but we can also do a number of other things. So we can develop metrics. So for example, what I've got here on the right hand side, this is the e-resilience measure that was developed back in 2016, which assesses the vulnerability of high streets to online shopping. And then more recently in kind of related research, there's been this emphasis on using mobility data to unpack the response of retail to various things, particularly the pandemic. So let's get on to what I'm doing. So in this paper, I'm using data from a company called SafeGraph, who are a US-based company. Originally, I was able to get the data through a COVID-19 data consortium, but they've now just released it all back again for academic use. So that's great that they're being so open and available for us. In particular, I'm using a data set called the Core Places database, which is a 6.4 million POI database for the whole of the US. basically where the places being where people spend money and or time. And from this, I was able to extract out those that are both retail specific and also specific to my study area. So as I said at the start, this paper is focused on the Chicago metropolitan area. So I've roughly ended up with about 106,000 retail POIs across the metropolitan area. And in terms of kind of accuracy and the credibility of this data set, SafeGraph themselves have performed some kind of accuracy checks. And in terms of their location, find that most of their POIs are within at least 10 meters of their actual location on a Google map. And they also find that around 99% of attributes are correctly identified in the data set. So it's a pretty good data set. And from what I know and from what kind of my supervisory team know about the area, it seems to be the best available for such a study. So let's get onto the paper. So the first part of this talk, I'm going to be talking about the where. So this is the scale and extent of retail centers and where they're located. So what we use is a inspiration from that modified DB-scan approach, but we address it by choosing a slightly different method, because what we found was that modified DB-scan approach was heavily customized to the data set that it was being used for, and there was a significant lack of transparency and quite a lot of complexity in its implementation. So we've gone for the more kind of what we argue to be the more intuitive and robust hierarchical DB-scan, which basically has the advantage of only having one optional input parameter, which is the minimum number of points to be deemed in a cluster. And it basically can automatically account for heterogeneous point densities. So for anyone who's ever used DB-scan before, this is a major problem with the algorithm as it produces a flat clustering otherwise. A particularly novel thing that we've integrated with the approach is that we've used network distance matrices, which we've computed through open source root machine to account for network distances between points rather than Euclidean, which, as we argue in the paper, we feel leads to a much better understanding of urban fabric by computing the kind of network distances between points rather than bird's eye kind of Euclidean. And the results of that clustering is a set of cluster labels for the points. But what we argue is that points don't themselves mark out the actual boundary of a retail center, and you need to go one step further. So we developed this quick four-step approach using the H3 spatial indexing system, which basically uses the points. So you can see that in that top left one, aggregate every point to a hexagon at resolution 11, pull out the 6 neighboring hexagons for each hexagon, and then you can extract basically tracts of contiguous hexagons. We have an additional caveat, which is that we only want centers 10 or bigger. This is to kind of align closely with the original boundaries that were done in that Pavlis et al. 2018 paper to enable kind of comparisons between the two studies. Okay, so what do they look like? So we basically, across the whole of Chicago, we found just shy of 1,600 retail centers. Typically, these were located in the central business district of Chicago, but also in kind of wider areas such as the main satellite cities of the metropolitan area and some of these major transport arteries. In the paper, we look at 2 key case studies. On the left, Chicago CBD, and on the right, Schoenberg Village, which is a kind of main shopping area of the metropolitan area. And we find that roughly, based on kind of consolidation between the co-authors, that we think the distribution of clusters is pretty good, and we're pretty happy with this. But there are a couple of limitations with the clustering and the center boundaries themselves. So firstly, what we found in the paper is that using point data only results in some unusual cluster shapes, because if you were to take the car park polygon for that mall there, you can see WC3, it would more than likely join up with all the other retail centers in that district. And as a result, you would end up with a very different distribution of retail centers. So using point data on its own is probably not enough. Secondly, because we use network distance matrices in the clustering, we had to restrict the clustering to a county level delineation, because computationally it wasn't possible to compute a network distance matrix of that size of 106,000 points. And then kind of thirdly, we're writing another paper on this at the moment, but we have got to try and find a way of actually empirically quantifying the cluster shapes themselves. And that's something that my peer review process highlighted quite heavily. So we're looking at potentially using mobility data to actually identify hotspots of retail activity and overlay that on the shapes themselves. Okay, so on to the second kind of part of the talk. So this is where we're talking about the characteristics, or I suppose the what of retail centers. So what are their characteristics, and how does that relate to them in the system of retail? We draw inspiration from this framework proposed by Les back in 2019, which argues that we should characterize retail centers non-hierarchically by taking 4 kind of key domains of retail: composition, diversity, size, function, and economic health, and using a data-driven approach to automate classification of retail centers. In my study, to adapt it slightly based on, because this is a Chicago paper, not a UK paper, I had used available variables that I could get to align as closely with those original ones in the framework, but obviously there are going to be gaps, so I had to fill in the gaps in a couple of places. Particularly vacancy rate wasn't available for my SafeGraph data, so I computed an economic health indicator based on some of the patterns database that SafeGraph have, which is kind of aggregated foot traffic data for the POIs. Additionally, I used geodemographics to account for neighborhood characteristics. So I used the US geodemographic classification, which was done in a paper by Seth Spillman and Alex Singleton. And then once you get the variables, of which I think I had about 24 in the end, I used 2 methods in sequence to run the classification algorithm. So we use principal component analysis, which is a dimensionality reduction technique to identify the most significant variables. And then I run an algorithm called PAM, which is very similar to k-means, but works much better for heavily skewed data. We actually run the typology twice, and I'll show you now why we did that. So on the left, we run it once to get out a set of broad groups of retail centers that were very different from each other based on these variables. And then we run it again to get a set of nested types within each group, enabling you to distinguish between some of the destinations from the other. So for example, the leading comparison destinations in comparison with the secondary comparison destinations. In terms of their geography, that first group of centers, as you would expect, they were at the main kind of cores of urban areas, some of those satellite cities, major neighborhoods, obviously Chicago CBD. Comparison destinations, obviously these big kind of comparison malls and things were classified in that way. Particularly interesting was that the leading comparison destinations were those main comparison places with like fashion outlets and things, and obviously the leading centers for that kind of thing. Whereas those 4th and 5th group of centers were typically dispersed throughout the metropolitan area. And back to our case study areas quickly. Again, interesting patterns emerged. Some of the places, so you've got the Loop here on the south side of Chicago and the Magnificent Mile. We were happy that those were classified in the way that we would expect. And then over here, you've got the Woodfield Mall is WC3. That's been classified as a leading comparison destination, which was really good and shows the value of an automated approach for doing so. But again, a couple of limitations before I move on. Obviously, a typology like this is inherently affected by the retail center boundaries themselves, because if the retail center boundaries change, the whole typology will change because you're looking at a completely different set of characteristics. So that's an issue. And you basically have to kind of ensure that you have perfect cluster shapes, which is very difficult to achieve. And secondly, it's a typology that's metropolitan, not national. It's based on characteristics within a certain area rather than across the whole of the US. So it's limited in its scalability. Okay, and thirdly, so the third kind of part of the paper, we demonstrate a use case for the retail centers that we delineate here. So that's all about how we can use retail centers. And I thought this was particularly interesting for GISRUK because our focus this year is on the pandemic and COVID-19. So what we've done is we've adopted an exploratory approach to look at how we can use a retail center classification like this to kind of unpack how different structures and functions of retail are responding to the pandemic. So obviously in the literature, there's lots written about this already, the impact of local lockdown on mobility, for example, or kind of the shift towards more essential goods rather than non-essential goods. So we thought it'd be interesting to look at some of these trends in relation to our typology. So again, I'm using data from SafeGraph and my retail centers, but this time I'm using patterns data pretty much solely. I gathered 12 months of patterns data around the kind of pandemic. So 2019 September to 2020 September. So we can look at kind of highlighting the role of the pandemic on these kind of mobility trends. And what we did was we calculated share change between different groups of retail centers to basically look at how mobility was kind of unevenly affected by the pandemic between these different groups. So some key findings, obviously you can see they're quite obvious. When the stay-at-home order was issued for Chicago, quite a drastic decrease in retail mobility. But particularly interesting was some of the kind of key trends between the different groups of centers. So if you notice that first group of centers, which we can think of as our main urban centers of retail, these experienced quite a staunch decrease in share of retail visits, whilst at the same time, the small local convenience centres seem to pick up a bit of share in visits, which is really interesting and sort of kind of fits literature around this area, that people were kind of shifting away from these large city agglomerations to kind of the small local ones. And particularly interesting is that when you look in the longer term, kind of more towards the end of 2020, the Group 1 centres still occupy quite a suppressed level of visits, suggesting that potentially there could be evidence for a speculation that high streets are actually on the decline in the whole. But I won't get into that because it's quite an exploratory approach here and it hasn't been possible to quantify it. But just now in the last literally couple of minutes, I just want to tell you a little bit about where we're taking this research forward. So obviously addressing the limitations that I've highlighted here in terms of the classification and the metropolitan typology, as well as the retail centre boundaries themselves, we've tried to build up a US national classification of retail centres. And I'll just whiz you through quickly how I'm doing kind of the where, the what, and all that. So in terms of the where, we've built a quick method that uses the H3 spatial indexing system, where it basically takes, instead of just points, we're using building footprints as well as land use polygons to identify all retail features. And then we basically can build up a grid of retail H3s and then start to build out tracts of contiguous retail centre boundaries. And what we end up, this is for a small area in New Hampshire, there's a nice set of retail centre boundaries. And the most kind of novel and most important thing is that it's really scalable and something that we can achieve for the whole of the US, which is a really difficult thing to try and do. And I presented this at GISRUK last week and people were quite happy with kind of the method and how it worked and things. So that's kind of reassuring. AAG, not GISRUK last week, sorry. And then in terms of the what, we've made a couple of modifications based on some suggestions from various people about what variables should and shouldn't be included. Particularly interestingly, we're using things that account for the urban fabric more this time around. So looking at road densities, building densities, but also employment in the retail sector as well, because this is what I found so far, is this has been really valuable in unpacking kind of major urban city centres from kind of main retail parks and shopping plazas and malls and things, which can have quite similar characteristics in some ways. So it's a really useful way of looking at that. And then the third and final element that I haven't talked at all about is to look at the who. And this is a really important thing in terms of who's using these centres and where are they coming from. And this is something we want to use as a quite novel element of this paper, as well as it being an extension to the whole of the US. We want to build catchments, we want to learn about who's using these. So there's various ways that we could do it. It's in its very conceptual stage at the moment. But what we're looking at is potentially either using origin destination data, which you can see top left, from Loads, which is the US Census Bureau, or using the SafeGraph data, which was done in a similar paper to build catchments for a convenience retailer. And we're working quite closely with a company called Geolytics, which I'm sure many of you are familiar with, on how we can do this and stuff. So keep your eyes out for it. But yeah, as I said, you know, I just wanted to keep everyone up to date with what's going on, and I'm making much more concerted effort to put all my code up onto GitHub now this time around. I learned a lot from doing the first paper, and I want to make sure that this time around I've got much more kind of cohesive track record of what I'm doing. So I'm learning a lot about reproducibility and everything as I'm going along. So do check out my GitHub if you are interested, because I have oversimplified the whole paper as a whole. So there's a lot going on behind the scenes. But for now, thank you very much for listening to my talk. Please do feel free to get in touch on Twitter or check out my slides if you're interested. But yeah, thanks for listening, and happy to take any questions from the audience.
First one from Chris Brunston. Are the network distances that you're using road-based? And is it possible or perhaps sensible to consider footpath or other network types?
Yeah, no, they are road-based. Thanks, Chris. That's a good question. Yeah, we use the open source Ruby machine, which in itself has been a whirlwind of a journey to try and get that to work. But yeah, they're road-based. But it definitely, now that I'm thinking about it, it would be much more sensible, because in some ways, like when you're talking about retail centers themselves, you're talking about the walkability of a retail center rather than the drivability, because when you're talking about drivability, you're talking about catchments and how far people travel. But when you're talking about the boundary itself and people being inside that boundary, it's more about the walkability and that. So I suppose that's a really good question, and something lots of food for thought there.
So next question from Stefano. How important do you consider localism to be in repositioning and regeneration of high streets and town centres? and how transferable is your research to the UK?
Okay, I'll answer the second half of that first. So in terms of how transferable my research is to the UK, it's actually being done at the moment. So Les, Alex, and Jacob McDonald, who's a data scientist in our lab, they're building up a new set of CDRC retail centre boundaries at the moment. And they've done that with the exact same H3 method that I've used for the US. So that's being done. And the plan is to do a multi-dimensional typology for those retail centres. So hopefully that kind of I hope that shows that there is a certain element of transferability. Obviously, there will be certain tweaks, as I've made certain tweaks in mine to account for kind of urban fabric and things. And they will probably use slightly different variables again when we're building out that typology, but there are elements. And also what I think is particularly novel and particularly valuable in this instance is that everything is automated and it can be redone. So it's very easy to take something and drop it into a different setting, adapt it to local context, and then rerun it and get it. In terms of localism to repositioning and regeneration of high streets and town centres, I'm not overly clued up on the whole concept of localism, unfortunately. But what I think is really important with this research is that we are taking, with this paper, we took local knowledge from Kevin. I don't want to drop you in here, but we took local knowledge to kind of verify that what we were doing is really useful and has value. And then what we're doing with that second paper is, again, using people from America and things, because I mean, I've got to be frank, I've only been to the States twice, so I don't know everything about retail in the States. So I think it's really important to take on board what people think and what people feel about this.
Next question from Nick Ham. How do you distinguish scale and extent? I assume of your retail.
Thanks, Nick, for that question. So in terms of scale and extent, I kind of wrap them up together really in this, because it's because the retail centre boundaries themselves are just the boundaries themselves. They're not aggregated to a unit. They're not aggregated to a certain scale or anything. They're just themselves. The only thing, and the extents obviously are the boundaries. The only thing that we do have to be careful of with this kind of research in terms of scale and extent, particularly prevalent in that second paper, is the H3 resolution. And I know there was a question in that last talk about the scale of that H3 resolution and how that can cause problems. And we've done a lot of work to make sure that the resolution we're working at is the best suited resolution to kind of unpick how connected retail is. For instance, I don't know if you're familiar with this, with the H3 library, we actually dropped down a resolution so that basically in H3, every resolution you drop down is 7 times smaller. So we dropped down a resolution to see what the connectivity of retail would be like. And what we ended up finding was, due to the kind of widths of streets in the States and things, they were actually not ending up with good shapes, because it was separating kind of 2 sides of a street as 2 separate retail centres, which isn't right. So scale and extent is very important. And yeah, we have done a lot of stuff on that.